If it cuts off again, I'm just going to have to give up. You ready? If I wanted to know what that was, there's something we talked about the other day that would help me out. No. Something we talked about the other day that was like with cube. We did a cube problem the other day. So if it was squared, it would be this row. If it was cubed, it would be this row. The important thing to realize is, so this would be squared, second power. Third power would be this row. So the nth power, can you tell me the first couple of entries of the nth power row? 1n. That's really all that matters. And what else is there? Other shit. Who cares? And we'll see why this is true in a minute. And it all has to do with the fact that if I'm doing this process, the limit process, and something ends up with an h coefficient, it's going to go to 0. And all I care about is the stuff that don't have the h, right? They're the survivors. You understand? Because I'm going to let h go to 0. So that somehow that's going to be the only surviving shit right there. I don't care about the other ones. Who cares what the numbers are? You could use statistics or probability counting theory to get them, but if there's an h attached to them, who cares what they are? They're going to die. All right, I don't know if some of you guys are with me or not. You'll see. Let's actually see what the hell happens. So how would I write the first couple terms of this? Let me see if you guys remember the idea. At first it's all x's, right? With the coefficient of 1, so the x to the n. Now how many x's, how many h's? There's going to be one more h, so one less x. Are you with me? So what would one less x be? So it's going to have this coefficient. What's one less x? And then one more h. And the next term is going to be shit with h squared, right? You with me? So you can already... some of you guys look at me like you just looked at limit. I'm sorry. Do you guys see the first couple? Yes? Yes? It's just like we did the other day. If I had x plus h cubed, it would be all x's with a 1 in front. Then it would be 1 less x, 1 more h with a 3, 1 less x, 1 more h with a 3, and then all h's with a 1. That's the shortcut. I'm not going to prove it for you. That's binomial expansion, whatever the hell you call it. Right? Binomial expansion. Right? Very creative names we give things. So I'm using the exact same idea, all x's, 1 less x, 1 more h with that coefficient. And we know that's going to be the coefficient because that's the pattern we see. I don't have to prove that. It's a pattern. That's how it's going to always happen. The next thing is going to be gross, but who cares? Once I divide by h, there's still going to be an h here, isn't there, for whatever term this is. So it's going to go to 0. So let's see it happen. Let's see it happen. So what's this look like? So it's going to be x plus h to the n, right? It's f of x plus h minus f of x all over h. That looks deceptively simple, right? Or no, I guess not. To me, just look at that. It's tiny. But then we all know that this is hiding a lot of shit. Right? So we already know how to write the important part.